Hello guys. I hope everybody is fine and today we would like to have a conclusion on a series of things that we talked about Bohr Einstein debate. Actually, it was all about Solvay conference. So now I think we must look into the conclusion of all these things that have happened till now. And the question arises that who won this debate? The debate that was going on between Albert Einstein and Neil Bohr. In fact, there were involvement of other physicists like Werner Heisenberg. It was John Bell. There was involvement of all these intellectuals who were trying to prove the side depending on the true nature of the problem that could be explained, that one could think of using some of the basic examples to counteract the argument of the other. I mean, between Neil Bohr and Albert Einstein. So, what we had the EPR paradox, we had Schrodinger's cat, Bell's theorem, and the experiments that forever changed our understanding of the microscopic domain, the microscopic world. And now, probably we must try to answer the question. Let's answer the question that many people have been waiting for. And the question is, as one of the students has argued this question, who won the Bohr Einstein debate? Now, at a very first glance, the answer appears very simple. And the answer goes with the experiments inspired by John Bell's theorem, especially those which were carried out by Alan Aspect in the early 1980s. And many increasingly sophisticated experiments in a decade that followed that experiment. And all the experiments that followed that experiment consistently agreed with the predictions of the theory of quantum mechanics, the predictions of quantum mechanics, and later experiments closed. They closed many important loopholes that were over there, and closing these loopholes led to strengthening the confidence in these results. And these experiments, they clearly violated Bell's inequalities, exactly as quantum mechanics predicted. What does that mean? That means local hidden variable theory of the kind that was presumed by Albert Einstein, hoped for, cannot explain the observed experimental results. The principle of locality argument has a failure. Now, if we ask only one question, which predictions were confirmed experimentally? And the answer to this question is pretty straightforward. It's quantum mechanics. Quantum mechanics was confirmed. The reality of the fact. It was confirmed as the right predictions. And the framework defended by Neil Bohr successfully described the nature of these microscopic systems. However, science is really as simple as declaring one person the winner and the other as loser. To understand why, we must appreciate Einstein's role. We must look for that role. It's not winning and losing the game. We must try to understand the role that was played by Albert Einstein, and we should look for it deeply. Remember something remarkable. Einstein never argued that quantum mechanics failed experimentally. He never ever argued it this way. In fact, he got his own Nobel Prize on quantum mechanics. He accepted its extraordinary predictive success. His concern was different. He believed that no physical theory should leave reality, fundamentally incomplete. He wanted a deeper explanation. He wanted a theory in which physical properties that are possessed by these particles, the physical properties that are possessed, they are definite. They have definite existence, independent of the observation, the impact of observation. Whether or not nature ultimately behaves that way. And Einstein's demand for conceptual clarity, it perhaps transformed the physics. His criticism was more fundamental. His criticism forced physicists to examine every assumption that they were looking for. And without Einstein's challenge, I believe, I mean, there might have never been an EPR paper. And without the EPR paper, John Bell might never have had developed the Bell's theorem. Without Bell's theorem, the revolutionary experiments that we have now, the revolutionary experiments on the quantum entanglement might never have had been performed. Now, in that sense, Einstein's objection became one of the greatest, one of the tallest gifts to the quantum physics. Sometimes a scientist changes history not merely by not by being correct in every prediction, but by asking questions so profound, by criticizing, by asking questions that generations of researchers spend decades answering those questions. That's exactly what Einstein accomplished. Now let's appreciate Neil Bohr, because experimentally Neil Bohr is on the winning seat. Now appreciate this man, Neil Bohr. Bohr recognized something extraordinary. He recognized something that was very complex, that was very difficult, that was very complicated. He understood that the microscopic world could not always be described using concepts borrowed directly from everyday experience. And he accepted that quantum mechanics required a fundamentally new conceptual framework, new conceptual basis, new conceptual postulates. His principle of complementarity, it basically encouraged physicists to think beyond Poisson brackets, to think beyond classical intuition. Although many of Bohr's philosophical writings, they remain challenging to interpret even today. His scientific leadership has helped establish this quantum mechanics as one of the most successful theories ever. I'm not boiling down the other fellows who developed the theory, but I'm just talking about this very strong starting point. And today, quantum mechanics forms the foundation of astonishing range of technologies that are racing in the globe. Every transistor inside your mobile phone depends on the laws of quantum mechanics. It depends on quantum principles. Lasers, you have magnetic resonance imaging, you image the body using MRI, and it's a consequence of quantum mechanics. You have semiconductor electronics, you have atomic clocks, what we call as cesium clocks, you have quantum cryptography, and you have this rapidly developing field of quantum computation. All of these achievements rest upon these ideas. They rest upon the ideas that emerged from the quantum revolution. And yet, despite this success, something fascinating remains true. And what's that? That is the philosophical questions, the questions raised by Albert Einstein. They have never completely disappeared. And physicists still debate the meaning of the wave function. They still investigate. They investigate different interpretations of quantum mechanics. You have different ways of calculating the wave function. And some are supporting the Copenhagen interpretation. And you have others who explore the many worlds interpretation theories. And then you have some who investigate Bohr's mechanics, and then you have others study the objective collapse model. Still, you have others search for new ideas that may one day extend quantum theory itself. Maybe there is a limit of that. And notice something important. All of these modern discussions that are going on in the modern world, they exist. Why they exist? They exist because the Bohr Einstein debate never stopped being relevant. It simply evolved. This basically teaches us one of the greatest lessons, one of the marvelous lessons in the science. What is that? Science is not built upon authority of somebody. It's not built upon the reputation of somebody. It's not even built upon somebody who claims to be the genius. Science advances through evidences. Theories survive. They survive because experiments continue to support them. The moment evidence contradicts a theory, scientists are open, they are prepared to revise their models. And that willingness to follow evidence, whenever it leads, is basically the greatest strength of this scientific method. The Bohr Einstein debate, it also teaches us another lesson. And what's that? That is disagreement. Disagreement is is not a weakness of science. It is one of its greatest power. It's one of its greatest strength. Einstein and Bohr challenged each other relentlessly, and they disagreed on some of the deepest questions that could be imaginable in those periods of time. But at the same moment of time, yet they respected one another as scientists. Their disagreement produced better questions, better mathematics, better experiments, and ultimately a deep understanding of the nature of reality. Now imagine if Einstein had remained silent. Imagine if Bohr had refused to answer the critics, to answer the questions that were raised by Albert Einstein. Physics would almost certainly have progressed, but very slowly. Instead, it was their intellect, it was their intellectual dialogue that becomes one of the greatest example of scientific reasoning in human history. So let's return one final time to our original question. Let's go back because we want to extract something fundamental from it. And what's that question? Who won the Bohr-Einstein debate? If the question concerns the experimental predictions of the quantum mechanics, then we have the modern evidence. We have modern evidence strongly supports the quantum mechanical framework. And this quantum mechanical framework is defended by Niels Bohr. And then what you have, the local hidden variable theories, which were proposed by Albert Einstein. And these theories, Einstein's envisioned those theories have not matched the experimental results that we have right now. But if the question concerns the advancement of science itself, then the answer is more profound. The answer is deeper. Science has won the job. Bohr won because the quantum theory he defended has been extraordinarily successful. And at the same point of time, Einstein won because it was his relentless questioning that forced quantum mechanics to become one of the most rigorously tested theories in all of science. So, neither man was merely trying to defeat the other. What they were doing, both were trying to understand the nature of reality. They were trying to understand the truth. That's why their